empirical rule to estimate the area under the curve, which also corresponds to the probability that the data falls within those intervals. So that empirical rule gave us 3 percentages. We know that plus or minus 1 standard deviation from the mean, 68% of the data lies. Plus or minus 2 standard deviations from the mean, 95% of the data lies. And plus or minus 3 standard deviation from the mean, our magic number was 99.7. We said that the other 0.3% is outside those 3 standard deviations from the mean. So how did we use that? Let's go through the homework and we'll talk about how we used it. Okay, so if you were asked to estimate the percentage of all values that are within 1 standard deviation of the mean, that takes us right to that. If the mean is here, 1 standard deviation from the mean was that 68% of the data. 68% of the data lies within 1 standard of deviation of the mean. So number 1 was a can I copy a number from my notes question. Okay? Number 2 was also can I copy a number from my notes, because it asked us to give the percentage that lies within 2 standard deviations of the mean. So this was straight off our notes, and it said that 2 standard deviations from the mean, 95% of our data lies. And then the last question you can see is number 3, and it is also straight from the notes. And it was, very good. It was 3 standard deviations from the mean, and that was our final number that I told you you'd be responsible for knowing, which is 99.7%. Okay, so whenever a problem asks you to estimate using the empirical rule, this is what we do. If you are estimating using the empirical rule. Now, the directions will not always say to estimate using the empirical rule. So what we do today is going to be a more exact number than an estimation. But whenever it says to estimate using the empirical rule, these are the numbers we use. Now, because the unit circle is symmetric, okay, if you interrupt me again, you're out. The first time I just looked at you, you ignored me. This is the second time. All right, so 68 divided by 2 is 34. So when we were looking at the area under the curve, this is 0.34 and this is 0.34. Now to find these 2 regions, what we did in class was we took the 95, subtracted the 68, and because the normal distribution is symmetric, we would divide by 2. So that 0.27 divided by 2 is 0.135. So that represents the area under the curve in these 2 regions. Now this next one, we get the same way. We would take that 0.997 and the 95, subtract those 2, and divide by 2. This is for 0.7%, which when we divide by 2 is 0.0235. So right here we have 0.0235. 0.0235. Now, out here, outside in these little tails, is that other 3.3% of the data. It's where our outliers live. So, 0.3% is like 0.003. When we divide that by 2, we get this. Okay? So now let's use this information. So we label our mean. If our standard deviation is 37, we just add 37 going this way, subtract 37 going that way. So now we have the lower bound and the upper bounds. So what percent lies within 1 standard deviation? 68. Lies within 2 standard deviations? 95. And this last one gave us all 3, 99.7. Okay, now, this one asks us for what was outside of these intervals. We know that the total area of the curve is 1. So if we're looking outside of this interval, and this interval is 0.68, then we could do its complement. 1 minus that gives us the 0.32 or 32%. So if we're looking outside of these intervals that we just found, it can be 1 minus the theta. Any questions about E, F, and G? Okay, now this was the first one that you really needed to do. You had to create your own curve. They weren't all plus or minus 1 standard deviation, plus or minus 2, and plus or minus 3. So you had to create your curve. You had to label the mean. You had to add to find the standard deviations. You had to know that these areas under the curve do not change. And then you just add up. This first one says between 162 and 170. Well, that's this interval. We don't have to add up anything. We just read it straight off. But this is between 170 and 186, so we have to add those two. This is between 178 and 186. We don't have to add anything. It's just right here. But this is less than 162. So it's this one, and that one. Add them up. Now, did you notice that D and F correlate? This is less than 162. This is greater than 162. So if everything under the curve adds up to 1, and we found this was 0.16, you could just do 1 minus 0.16 to get the rest. All right, so take a look at those. All right, I will tell you, those of you that are actually doing your homework every day, and right now it's actually not a bad percentage in here, you guys are going to be fine for next week. I'm really concerned about those of you that are checking in and out, or checking out more than checking in, and not doing that homework, because statistics is like a new language, and if you're practicing what we're talking about every day, you're going to be great. You're going to be fine. Even if you miss a day for AP testing and you come back, you're still going to be fine if you check back in. If you're waiting until next week to try to meet with a tutor right before the test, and you think 1 hour is going to do it, you're just going to leave there so confused, and you're going to be sad. So let's preempt that. I do know that almost all the other teachers are testing this week to make sure their students aren't lagging behind. I chose not to do that because I have so many that are out for AP testing Friday and Monday. And then I have a bunch more that are going to be out Wednesday. Yeah. So I was concerned.
This is our last test.
This will be your last test before your final, unless you're exempting the final. So you guys probably have an opportunity to exempt more because you had 2 milestones. So that opens up the door for more exemptions. So some of you might be able to exempt. Yes, sir.
A question on this. So for the less than or the outside ones, couldn't you just add outside of those intervals and then be the answer also?
We could use the fact that this side and this side are symmetric and then add those up, yeah?
Yeah.
Or like for this one, you're right. Greater than 162, we could just start adding this plus this plus this plus this plus this. Yes.
Yeah. Because for D, I add them all together and I got 15.85 because.
I think you forgot this little guy right here.
So we have to add include those in our.
Yes.
Okay.
Yes.
Okay.
So yes, the part that's outside 3 standard deviations we have to have so it accounts for all of it.
Okay.
Okay, and then this one was finding that area under the curve, which is the probability, and taking that probability and inferring it on the population. So if we did that probability times the number of days, this is what we would get. If we did this probability times the number of days, this is what you should expect. 253 and a half of those days, we filled over 16,000 bottles. Now, this last one, part C, we've had some discussion about should we just subtract those 2 values? on part C? Did any of you guys subtract those two values? Or did you just... Well, this one could be read differently, and I'm going to be really clear on a test whether I want you to subtract the two probabilities. That's what we're going to practice more today. Okay, so when you guys came in, you picked up two sheets. One looks like this, except it's not colorful. And the other is a chart. So today what we're going to do is actually get to the statistics where we can do comparisons. And the one, we looked at normal distributions on Friday. And if you had done your homework, you would have noticed that the mean on every single problem on your homework was different. And the standard deviations on every single problem was different. Because we can have an infinite number of normal distributions. They can have all different sorts of means and all different sorts of standard deviations. But when they do, it makes it hard to compare two different things. So what we do is we take all that data we have and we try to make it so where we can compare. And the way we do it is we transform the data. We take that data and whatever the mean of that data set is, we shift it back to where the mean is 0. So how do we shift something back? We would subtract. So if the mean was 70 and we wanted to shift it back so that the mean becomes 0, we would subtract that mean. And then because our data sets can have any type of standard deviation, and we looked at that the other day on our graph, we know that can stretch out our data or it can squinch it up and make that curve really tall. But if we take our data and divide by the standard deviation, so if our data had a standard deviation of 5 and we divide it by 5, what is 5 divided by 5? 1. We forced our data to have a standard deviation of 1. So by shifting it, by subtracting the mean, we force all the means to turn into 0. And by dividing by our standard deviation, we force all those standard deviations to turn into 1. And what we do when we make that conversion is now we can use a standard normal comparison. And what we call that a z-score. So when we transform that data, what we do is we create a z-score. Now a z-score, we can compare different things. And that's what we're going to do. We're going to compare an ACT score with an SAT score. Well, ACT and SAT don't even use the same scale. ACT is to 36, right? Maybe? And SAT, math and verbal together, 1600. So they're very different scales. But we can compare test scores even on two different scales. And don't colleges do that? Some you can submit either an SAT or an ACT score. So they're doing the same types of comparisons there. So what we do to make those comparisons is we're finding the z-score. Now a z-score is that standard score for the data, and it indicates the number of standard deviations the data value is away from its mean. So this is the formula we need to know. Our z-score is the data minus the mean, divide by the standard deviation. Data minus mean, divide by standard deviation. Data minus mean, divide by standard deviation. And we're going to work on that today. Okay? So, now when we find a z-score, we can find the probability or the area under the curve associated with that z-score. And that way we can compare things that are not the same. All right. Now, the first thing we need to learn how to do, though, is to read our little z-score chart. And you guys should have picked up one of these as you walked in. Everybody pick one up? All right. Now, when you look at the chart, it says standard normal probabilities. So this is our standard normal chart. And it says the table entry for Z is the area under the standard normal curve to the left of our Z-score. So it's always giving us the value for the area to the left. So if I ask you to find the area under a standard normal curve to the left of a Z-score equivalent to negative 0.99. So if we sketch that out, and we know with a standard normal, every time this is 0. So if I come back and say this is negative 0.99, this is the area to the left of that. So it represents this area. Okay, so that area under the curve is the same as the probability. So if we're looking for the probability that our Z-score is equivalent to negative 0.99. Now left is like less than. Left is less than. So it's less than negative 0.99. And let's take out that chart, which I did have up a second ago, but I think I've closed it. Nope, it's not up anymore. Here it is, though. We'll open it right back up.
Should we go and shop as a ticket?
There it is. All right, so we're looking at the negative side because the first Z-score I asked you for was negative 0.99. So there's the 9 down there.
I found it.
Let's see if we can make that little black spot go away. There we go. And if we look at negative 0.9, so this is the tenths place. And then the 0.9 part is right here. So this intersection of negative 0.9 and 0.09 represents a Z-score of negative 0.99. Do you see how to read it? This gives you the tenths. Across the top gives you the hundredths. The intersection of the two gives you the value. Okay? So this is 0.1611.
And we're gonna get this on our tests and stuff?
You will have a chart to use on your test. Yes, ma'am.
Alright.
Okay? So I want you to try to find the area under the curve or the respective probabilities of a Z-score that is less than negative 3.22, less than or equal to, less than or equal to 0.18, that's good, and then greater than or equal to, let's do a positive one, positive 3.22. Okay, let's see if you can read the chart. If you're not sure how to read the chart, please let me know.
I don't know how to read this chart.
Okay, I'm there.
I'm completely unsure how to read this chart.
Okay.
0.0006.
Yep.
Can I help you?
Negative
Can I help you?
3.22.
Do you mind if I step in here?
So the intersection of those two, right there. So the first one I asked you was negative 3.22. So there it is.
This side
That's right.
gives us our negative 3,
Mhm.
and up top gives us our 2.
Actually, you're really close.
You're wrong.
You're really close.
0.32.
Let's go negative.
Oh, they.
Let's go negative. There we go.
We have the negative 2.
3.2.
And then what's our last place?
2.
There
So I
we
have
go.
to flip the chart over.
Yes.
If it's
Yes.
positive.
That's all
Yes.
on yours.
Yep. Okay, guys. For my other class, I printed the positive and negative on the same page. But it looks like this. And the numbers were so tiny, and I was watching my students squint and put their faces really close to it. So I decided to do it front and back for you guys, which means one side of your chart gives you all the positive values, and the other side of your chart gives you all the negative values. So just make sure, as you're looking, you're on the correct side of the chart to start with. Okay, anybody else have a question?
I didn't finish, but were you doing calm?
I know, she got one.
I have a feeling you were doing calm.
The normal or it has like
I wasn't,
he was
though.
still
You're not
the
up
same
for grammar.
number.
I was
He's
building a
borrowing
bridge.
me for the
Even if it just says like Z
Like,
less
see
than
how
Got my
fast
answers on this
24.22. It's the
I
same
gave her-
number as the second.
Yes, yes.
It's just telling you like,
Bridge builder. I got all the
Made out like
answers.
an
this is
That's sick.
the
left
max,
It's all
basically.
top.
And that'd be like the minimum. It's also equal
My little cousin gave it to me.
to, like, it could be this, or
Yeah.
it has like the.
Less than or less than or equal to is the same on this
And
chart.
I.
Yes, ma'am.
Joel, Lexi has one, but that one's. Okay.
Are you asking me about this last one I already got? Okay, that's a different kind of problem, and you're gonna have to keep trying those probabilities when we get there in a second. Okay. All right, so I can tell from the chit chatter that most of us are done. So when we're looking for the probability that the z-score is less than or equal to this, did you guys get 0.0006? Okay, so that represents the area under the curve, which is equivalent to the probability. So the area under the curve for the positive, 0.18. Did you get 0.5714?
Yes.
Okay? And then finally, this one. Ooh, I said greater than, didn't I? Now I know why you're confused. I meant less than. Okay, I'm really sorry. That's what all your questions were about, Ansley, and I wasn't paying good attention.
Okay.
Okay, this should have been less than because I wanted to do to the left for all of these. We're going to do greater than next. Okay, but 3.22, and that should give us 0.9994. Now,
999.
the reason I wanted us to do both of these is because this helps us think about or brings back to light the normal curve has symmetry. So to the left of a z-score of negative 3.22, this area right here is going to be the same as to the right of a positive 3.22. So this area right here, 0.0006, is going to be the same as that area right there, 0.00606. Now, huh?
Why is the number?
Okay, because I accidentally said to the right to start with. I didn't mean that. If we are solving this one, a z-score that is less than or equal to that, when we're less than, what we're looking for is all of the area to the left.
So it would basically be that number minus the 0.006.
So what this is 1 minus that 0.0006. Okay, now, why, the other reason why this is helpful, because sometimes we want to the right. Sometimes we do want greater than. To the right is greater than. So there's two ways we can find to the right. We can do 1 minus the probability that is less than, or we can just find the probability of the opposite. Because if we think about the normal curve, greater than a positive 1.6, greater than a positive 1.06 is this right here. So we can either do 1 minus the less than, and the less than would be all of this, right? So that's what the less than is that shaded part. So we could do 1 minus the less than, or, this is easier and better, or we can just do its symmetry. Z is less than or equal to 1.06, which is the exact same area, because it's symmetric, on the other side of the curve. And let's prove that this works. If we looked up a positive, a z-score of a positive 1.06. So 1.06 is 0.8554. So if we did 1 minus that, that would give us this pink part. But let's notice that this is actually equivalent to the negative 1.06. Because of the symmetry of the curve, this area is equivalent to that area. So there's 2 different ways you can do it. Now the second way is quicker. And you guys usually like quicker, easier.
1 minus.
So whenever I give you greater than, so if I ask you to find the probability that z is greater than 2, that is going to be the same as the probability that z is less than what? Negative 2. Because of the symmetry of the curve. Okay, and negative 2 would be 0.0228. All right, you try. You try to find the probability that z is greater than negative 0.81. Greater than negative 0.81, or to the right of negative 0.81. Okay, try this.
Okay.
186.
Is she going where?
Is that so nice one?
So we go to Z of point.
So you do the opposite of what it says.
Because that guy's.
Yep.
Alright.
Whenever it's greater than, you do the opposite.
When it's greater than, I'm really gonna do less than.
Where's
Yep.
point 8?
Because
I'm gonna do a positive 0.81.
this area under the curve is equivalent to this area under
So
the
I'm gonna
curve.
go to positive 8.1.
Yep.
Positive 0.8.
So we can show that. Where is it?
So if we're looking for a positive 0.81, here's 0.8.
0.7910.
Ah, that makes sense. Are you getting sick? You getting sick? That's totally sick. Oh gosh. Here's the hand sanitizer.
Alright, last example of using z-scores. So if this was 0, and we're looking at negative 2.16, and a positive, a negative 1.35. Okay, so we're looking for the area in between, which is that, isn't it? That's the area in between. Okay?
Okay.
But when we look it up on the chart, this negative 1.35 gives us this and this. It's all that, right? And then when we look up the negative 2.6, it's just the green part. So when we look this up, it's the blue and the green. And then we look this one up, it's just the green. Well, if we want the area in between, we don't want the green. So we want this to go away. How do you make stuff go away? Subtract. So what we're going to do is we're going to take the probability that the z-score is less than, and we take the bigger number, which in this case is this, and we're going to subtract away the probability of the smaller one. And that gives us what's in between. So whenever we want to find between, what we do is the bigger one minus the smaller one. And that leaves us what's in between. Does that make sense? Okay, so look up these two. Let's see if you can read that chart.
Big minus small. And I'm looking for when it's greater than or equal to.
It's .088.
These are less than, so we don't have to switch it. So then we go to
And then you
negative
switch right now.
1.3.
They're on chopping it.
.0885. Oh, aren't you just something? You want 555?
Was I surprised with that? Yes, please.
Hey,
Whoa, what about four?
Yes, I've been trying to order.
Oh, yeah, it is.
Miss
You're right.
Nicola.
All right, questions. Okay, so that was learning a skill on how to read the chart. So now let's apply it. Okay, when answering word problems, generally you're going to have to find that z-score first. Then you're going to sketch the curve and shade the region you're looking for so that you know how to read the table. Then you're going to use that table to find the area of the curve to the left of that z-score and then answer the question. So this one, suppose that the mean time a typical American teenager spends doing homework is 4.2 hours per week. Assuming that the standard deviation is 0.9 hours. Assuming variables are normally distributed, so we're normal distribution, find the percentage who spend less than 1.5 hours. Less than, left.
You mean 3.5?
Excuse me, 3.5, correct. First, find the score, z-score for x equals 3.5. So what is the z-score when our data value is 3.5? So it's data minus mean divide by standard deviation. That is how we shift it back to 0. So data minus mean divide by standard deviation. So 3.5 minus 4.2, enter, divide by 0.9. And because our z-chart, our normal distribution chart that we're using, has 2 decimal places, let's all round to the nearest hundredth. And this is negative 0.78 when we round to the nearest hundredth. So we're rounding here, and that is our corresponding z-score. Now, we want less than 3.5, so if we were to graph this, we're looking for what's over here, a z-score of negative 0.78. That's what we're looking for. Well, the nice thing about this is we can read it straight off the chart. So, the probability that I spend less than 3.5 hours is equivalent to the probability that the z-score is less than negative 0.78. Please read that z-score off the chart.
So where'd you get the negative 4? Oh, okay.
The chart. The chart.
Hours.
Negative 0.7.
Okay.
That makes sense.
So we got
Okay,
negative.
the first thing to
we
do
got
is you take
negative
the hours they tell you
Right.
and convert it to a z-score.
0.7
So
negative.
hour minus the mean divided by the standard deviation.
And let's go all the
That
way
gives
down
you
to
the z-score. And the z-score is what you look up on the chart.
0.2177.
Right.
Okay, so now let's answer the question. What did the question ask? The question asked us to find the percentage of teenagers who spend less than that. Well, if this is our decimal, that is 21.77%. Please make sure you answer the question that was asked. So we'll just change that decimal into a percentage. Okay. The next one, the average height of an American male is 69.2 inches. If the standard deviation is 3.1 inches, determine the probability that a randomly selected adult male will be at most, is it that less than? Less than 71 inches tall. Assume it's normally distributed. So the first thing we have to do is take that height of 71 and convert that to a z-score. So, height minus mean
69.2.
divide by standard deviation.
So that's the mean that you subtract.
This is always what they give me. This is always the mean. This is always the standard deviation. Okay? So in this case, 71 minus 69.2, enter, divide by 3.1. This time we get a positive z-score. When we're going to round that z-score to our nearest hundredth, so we can use that table, 58.58. So what we're looking for is a height that is less than 71 inches. But that height converts to a z-score that is less than 0.58. Please look up the z-score for positive 0.58.
That's the formula. In that first part, that's the
0.7190.
Yes.
Okay, that's what I'm trying to figure out. Score instead of 0.71.
And so that is the answer to the question. The probability that a height of a randomly selected adult male is less than 71 inches tall, that probability is fairly high. 0.719. Yes, sir. Mhm.
It's for
I didn't do
Hey,
it.
what's your favorite color?
it's for me.
Is it really?
Going home.
I got
All right.
Oh, I thought you did.
Example 2.
Hold it. I got all my papers together and stacked them.
Okay, now, example 2 is pretty cool because it's the next type. It is our greater than. This section is for to the right. Anytime we have greater than, we're looking to the right. So, let's remember, with that standard normal, to the right, is going to be the same area as to the left of the opposite. So, the average on the most recent test was 73 with a standard deviation of 8.2. Assume the test scores were normally distributed. Determine the probability that a student scored an A on the test. So what we're looking for is the probability that that student's score was above, greater than or equal to 90. That gives us an A here at Stars Mill. So we're going with greater than or equal to a 90. So the first thing we have to do is convert this score of 90 to a z-score. So data minus mean, divide by standard deviation. And then we're going to round that z-score to the nearest hundredth. And we should get 2.07. So we want a z-score that is greater than 2.07. Now remember, because this area right here to the right of 2.7 is the same as to the left of negative 2.7, 2.07. I keep saying 2.7, 2.07. It's easiest to look up that z-score that is less than negative 2.07. So if we did it this way, we'd have to do 1 minus the data. Here we can just look at straight up. So, find a z-score of negative 2.07. And we should get 0.0192. If we looked at the positive 2.07, you'd have to do 1 minus that. And you see if we did 1 minus this, we'd still get this. Alright, but it says determine the probability. So, the probability that they scored greater than a 90 is 0.0192. 0.92. That's not good. It's bad. That's poor.
It's like Mitchell taking every test.
He's at 1%.
No, he gets all the C's.
All right,
Probability of Mitchell getting an A.
gotcha.
Oh,
That's not
that's
very
not.
nice.
Okay. B. Women's heights are approximately normally distributed with a mu of 65.5 and a standard deviation of 2.5. Find the probability that a randomly select woman would have a height of at least 64 inches. So we are looking for a probability that the height is greater than 64. At least, this gives us greater than. So we need to convert that to a z-score. Greater than, you convert. Please convert the data to a z-score.
Oh, okay. The z-scores. So we need, none of them work except for this one. So what we have to do is,
Okay.
oh, I'm not saying how it is. What's the X? Miss Wildy?
May I get some agua?
Miss Wildy? What's the X?
It's usually what they're asking you for. So X in this case is 64.
Oh, okay, so we just plug that number in for X. Alrighty, now we get to the calculation. Here is 64 minus 65.5.
Wilby?
Yes, sir.
Karen, is that yours?
Alright, so we're gonna switch it around to.
No, Karen, it's all right over there.
And we're gonna make it 0.6. And then we're
Uh,
gonna. And if I'm correct, the chart tells us we have 0.72.
Cole, right, so short step.
So, Friday, you guys have a game, or cheerleaders, do you not sure what?
Find the probabilities and subtract them.
Did you get
Okay.
72.5.
So,
No.
we want it greater than a negative 0.6, which is the same as the probability that z is less than
Yeah.
a positive 0.6. Because the area under the curve is the same. Because we have a normal curve, it is symmetric, we can read it this way. So, did you guys get that the probability that a randomly select woman would have a height greater than 64 inches would be 0.7257?
Good word, Cole.
Okay, now the last one, number 3. This is where we're doing the between. So remember with the between,
You gotta subtract.
we subtract.
3.
Now, what we're going to have to do is convert both of these values to z-scores before we can do that larger value minus the smaller. Okay, so according to College Board, Georgia seniors graduating in 2008 had a math SAT of mean of 493 with a standard deviation of 108. Assuming the distribution was normal, find the probability that a member of the class of 208 scored between a 500 and an 800. So we have two z-scores that we have to find. A z-score for 500 and a z-score for 800. So data minus mean, divide by standard deviation. Data minus mean, divide by standard deviation. So we have to convert both of these to z-scores. The probability that our SAT math was between 5 and 800 is the same as the probability that our z-score is between, we gotta find these two values. So 500 minus, divide by 108, round to the nearest hundredth, this is 0.06. 800 minus 493, divide by 108, is 2.84. So this is 0.06. This is 2.84. So we have to find those two and subtract. So we'll start with the larger one, 2.84. Okay, and 2.84 gives us 0.9977. And 0.06 is 0.5239. And then we subtract those two. And that gives us a probability of 0.4738, so almost 50%.
I just understand.
So you paid attention to the entire lesson.
I understood this.
I'm really proud of you.